So I will present the next part of the course. Again, the book, the chapter in the book we are talking about. So I will present roll stability, pitch stability, yaw stability, and feedback control. Again, a reminder of the 6 degrees of liberty from a shape. We are going to talk about the rotational movement. Roll motion, main causes of roll motion is like waves forces in a beam C, wind forces, or cargo moving on the deck, or something like stuff like that. Some other consequences of rolling motion is like possibility of capsizing the ship, seasickness as well. To solve that, you can do a modest value of metacentric height, or use some device to control that rolling motion. So volume stabilizing mechanism is like this. Like you need to have a stabilizing force equal to the TP force in the opposite way. There is like 4 main way of controlling the roll is first the bilge keel, the stabilizer fin, the anti-rolling tanks, and the rotor roll stabilizer. First, the bilge keel is like some little fin fixed on the hull below. Just creates some counter force when there is a rolling motion. It's approximately perpendicular to the roll near the turn of the bilge. Yeah, and it can cause mass undamping. Next, there is a fin stabilizer. It is kind of similar with the bilge keel, but instead of being fixed on the hull, it's moved. Like there is a it can be controlled automatically. So by that, like if there is a greater force, like by moving the fin, it can create an alternative force. Yeah. Third one is like anti-rolling tank. For that, there is a video that you can explain it a little better. You can see like by separating different tanks into different little sections, there is less rolling motion than just filling as a full tank instead of. And this one is like another type of rolling tank too, when it's controlled by pumps or something like that. That's a different amount of water on each side of the ship. There is the rotor roll stabilization, where it's like a passive way, like the bilge keel, when there is a big rudder behind the ship who can create a rudder force also against the tipping motion. So here, one of the comparisons between these 4 technologies, like you can see the bilge keel is like, as I said, simple and inexpensive, but like the improvement of that, the stabilizer fin is like more effective, but it's more expensive than the keel. Anti-rolling tank is like effective in all speed, speed ranges, but it's require a large space and it creates more weight. And the rudder roll stabilization, like also small space, but inexpensive, but it's ineffective at low speed since like there isn't any force at low speed against the rudder. Here there is some other ideas. People imagine like first there is the gyroscope. There is a video for that as well. That's the company who made that. Just a gyroscope in the ship. There is also the best mirror saloon, like it was invented in the 19th century. Basically, like he wanted this part is the saloon, and like he wanted that part to be fixed and just the outer part of the hull to move against the sea. But he didn't make it the year after that. Like it was maybe too advanced for his era. Here's the equation of rolling motion. It's a differential equation. So pitch motion, it's main cause of wave force as well. Sometimes ice breaking motion when you're in an icebreaker. One of the consequences is like you can have water on deck because of that pitching motion. There can be structural damage due to slamming, propeller racing, and motion-induced inertia force as well. To counter that, you can either change the speed of the course or your ship, or have an appropriate load distribution, or have some horizontal speed. Here there is a video of like a cargo ship when there is a lot of pitch motion. See water coming on deck. Here's a question of that pitch motion. Mass spring dimple model, like you can evaluate the ship by that mass spring dimple model as well. And for the yaw motion, causes like always wave forces or vessel towing. Consequences like course deviation, broaching, I will explain you the word broaching later. One of the consequences, like you can cure it by trimming the stern, rudder string, or having an anti-yaw skeg. Broaching in sailing is like when there is a, for example, into a ship like that, and there is too much wind force against, and that make the ship tip or almost capsize because of that. So yeah. See here the yaw stability. Like first, you can see here when it's unstable, and other way of stabilizing the yaw by using straight line stability, directional stability, or position stability. So of course, stability versus maneuverability. Stability is like the ability of returning to an equilibrium state, returning to the main state after a disturbance. Maneuverability is the capability of moving a vehicle out of its equilibrium state to a desirable state. So you need to have a trade-off between those both states. So a stable vehicle like tends to just stay in the equilibrium and it's difficult to maneuver. But if the ship is more maneuver, like it's less stable, so you need to have find a way to have a good stability and maneuverability as well. Here it's a question for course keeping autopilot. Yeah, I don't have like too much to talk about that. Like so dynamic positioning is like when you can see like for a research vessel or something like that, when it needs to stay into the right position, you can see like they have a lot of thrusters around the ship to make the position stable against all the other disturbance outside. That's all for me. Thank you. Thank you for watching.
Right. I should let Emily share the screen.